Dogs. Man's best friend. These cuddly canines are more useful than we give them credit for, providing us with companionship and assistance for as long as we can remember. Even if you're not a dog lover, you can't deny their usefulness on a day-to-day basis, whether it's providing security at an airport or guiding the blind through their daily routines. There are approximately 8.5 million dogs in the UK alone, all living in a variety of environments and roles. Only 55 of all these dogs have been trained in the latest area of medical research as specialised medical detection dogs.
Medical detection dogs, what actually are they? They use their powerful sense of smell to pick up small chemical changes in diseases such as cancer. I'm going to be speaking to some experts about medical detection dogs and the science behind what they actually do, and why this research is so important into diagnosing cancer earlier.
The medical detection dogs are trained to react in a particular way upon the detection of a specific disease-identifying odour. In this case, the displayed behaviour is simply sitting and waiting. This clear behaviour allows the trainer to monitor the dog's learning progress. I've come to the University of Sheffield to meet an expert from the Biomedical Science Department. Dr. Andrew Lynn will help me understand how the sense of smell works and how we can use dogs to identify differences in patient samples. So could you tell us why a dog's sense of smell is so much better than ours is?
In terms of diversity, dogs just have a lot more different types of olfactory receptors. Humans have about 300-400, dogs have something like 800. And in the same way that dogs are red-green colorblind because they don't have different photopigments for red and green light, humans are, you could say that we're kind of smell blind because we don't have as large a range of different olfactory receptors for detecting different kinds of odor molecules.
So how sensitive is a dog's nose and sense of smell?
Extremely sensitive. A dog can detect 1 part in a trillion. That's approximately 10,000 times more sensitive than a human.
So a dog can detect 1 part in a trillion. That's the same as a quarter of a teaspoon of sugar. In all of this water!
Now I know how the sense of smell works, I want to see how this can be put into action. I'm going to talk to a local dog trainer to learn about the practicalities of training a dog and why their powerful noses are so important to them.
I'm here at the park today to talk to a dog trainer about how we can relate dog training to medical detection dogs. So we're here with Phil and the very handsome Pringle. So Phil, how does Pringle associate a reward with an action?
I think the answer to that is, it is simply what happens when he does that action in his mind. If nothing happens, then he passes over it and thinks it's of no interest. But if something immediately exciting happens or interesting to him, he relates it to that action.
Okay, so with the medical detection dogs, we can have the same principle with training them. So the immediate action of giving a reward once he does something good.
Yes.
Yeah. So as soon as he smells the right thing, then we give him a reward, and he knows to do that again and knows when to do it again. So in terms of sense of smell, we know the dogs have incredibly powerful noses. What's your personal experience with dogs and their smell?
It's another world to us, because the best that we can do is oppose second to anything he can do. They live through their smell. They don't look as we do. He's constantly scenting around, and that's his world. Whereas we look, the dog is way through scenting.
Is it easier as a puppy to start training them?
It is, and the thing is with a puppy, it is learning, and the brain is developing as it grows.
Yeah. Well, thank you very much, Phil, for your
Pleasure.
time, and it was lovely to meet the gorgeous Pringle.
Research into these amazing animals and their incredible anatomy could be the key to diagnosing serious diseases earlier. The long-term goal is to create a bionic nose that GPs can have in their surgeries. The bionic nanonose uses a patient's urine sample to detect the presence of cancerous cells. Using proteins similar to the receptors in a dog's nose, the nanonose can differentiate between the protein levels of a healthy or diseased sample. If research continues to be funded, these little guys' noses could be the future in the battle against cancer.